Resolving defects and debugging issues is an inevitable part of software development, but it doesn't have to be painful. In this video, I would like to share with you 3 tips for mastering defect resolution. I'm not going to get into specific skills or tools or techniques in this video. I will address those in later videos. What I want to share in this video is really the core guiding principles for mastering defect resolution, where if you master these principles, then the rest will become easy for you. So the first principle that I want to share with you is to be curious. Understand how the software works and why it's behaving the way it is. Curiosity is the gateway to opportunity. So you want to avoid quick answers that cut off further investigation. Answers like, well, maybe it's the network, or it's probably bad data. While those may be true, they could cause us to miss an opportunity to discover something important. That something important could be a problem that we didn't know we had, or it could be the cause of a problem that we've been experiencing, but we didn't know why. Have you, in the course of testing a solution for a feature or a defect, come across something you couldn't explain? Did you follow up on it? If you did, you may have uncovered an edge case that your solution didn't address. Or the changes that you made as part of your solution may have unmasked an issue that was present but we had not seen. I know that's true for me, but I also have seen cases where digging in and looking into an issue and uncovering what's happening has led me to discover the root cause for a problem that we were having, but we couldn't reproduce it. We didn't know what was causing it. If you want to talk about having an impact and getting recognized, go to your leadership and say, while working on my issue, I uncovered this other issue that we didn't know we had, and I've resolved it. And you'll look like a rock star. So embrace your curious mind. Now, you do need to have some balance, and you do need to be aware of priorities. It may be the case that you can't afford right now to go chasing down that issue in detail. It may be that you can't afford to get sucked into a rabbit hole. But do at least have the curious mindset. Do at least want to know why this is happening. And at a minimum, at an absolute minimum, document your findings. Never let the gift that is an observation of an issue go unrecorded. Because that observation could be the key to unraveling a mystery when we look into that issue in the future. The second principle that I want to share with you is that it's all about the assumptions. Every defect is the result of a failed assumption. And understanding the failed assumption is the key to creating a robust solution. What do I mean by that? A robust solution is a solution that is least likely to have gaps or edge cases that it doesn't address. So if we have a function like this example here, set value that takes an object as a parameter and is going to access a value on that object. Now it's obvious from the code here that if the object is null, this is going to fail. And so I would look at this and say there's an assumption here that that value can never be null based on how the code is written. Now, if you were working on a defect and you had traced the issue to this point and the value being passed in was null, then you might conclude that That is the root cause. And you might conclude that the proper fix is to put a null check in. And that may be the case, but it may not be. If the assumption that the value cannot be null is invalid, meaning that there are normal conditions under which that value will actually be null, then adding a null check is the correct corrective action in this case. But if the assumption that that value should not be null is valid, meaning that there is no reason why that should happen, then our root cause analysis is not done. The root cause hasn't been determined until we find an invalid assumption that is driving the errant behavior. So we need to go and be curious, going back to our first principle, and figure out why that value is coming in as null. Why? Well, because if we simply take care of the problem here and add a null check, we may very well end up fixing the defect. But we may actually only just mask an issue that's going to cause us problems in the future or continue to cause us problems. In other words, the key to finding the correct solution to a defect is to understand the assumption that failed in order to cause the issue to take place in the first place. The third principle that I want to share with you is to separate your observations from your evaluations, or if you prefer, your facts from your opinions. Now, why is that important? Well, there are these tendencies called cognitive biases. And cognitive biases are a tendency to interpret information in a way different than the information warrants. A great example of cognitive bias that we deal with in software is confirmational bias. A confirmational bias is a tendency to attach more weight to information that confirms what we believe, or to interpret information in a way that confirms what we believe versus a way that contradicts what we believe. One of my favorite authors, Michael Sullivan, has a great quote about this. He says, "It is often easier to believe the most outlandish lie that confirms what we suspect, rather than the most obvious truth that denies it." Now, the key to combating confirmational bias, and indeed many of the cognitive biases, is to separate what we know from what we think it means. You want to, when confronted with a problem, write down everything that has been observed about that problem, everything that we know, every irrefutable fact. And you want to look at that list and you want to make sure that there's nothing in there that's actually an opinion or an evaluation or an inference. It's natural to want to draw conclusions and come up and have opinions about what's happening. And there's nothing wrong with that. In fact, that's an important thing to do in defect resolution, is to come up with inferences about the information in order to come up with potential paths to a solution. But those inferences can be tainted by bias. Whereas the facts, the observations, are pure. They're fixed. They're safe. It's an anchor that you can always come back to. And in fact, many times when I am working on an issue and I start to feel that I am going down a rabbit hole and I'm not getting anywhere, I will often take a step back and come back to what do I know and record any new things that I haven't captured. But resetting back to what I know. So you want to keep these things separate. And you want to make sure that you're testing everything you are inferring or believing that the information means against the observations. And if there's an observation that doesn't align with an inference, then you have to reconcile that. And you can't reconcile it by throwing the observation away. Now, it may be the case that there's another explanation for that observation, in which case your inference is still valid. But you have to get in there and figure out why there's the discrepancy. Now, why is this important? The solutions that are driven by our cognitive bias will never be the solutions for the defect. What the cognitive bias will do is it will cause us to spend time exploring solutions that are not, or causes that are not the root cause of the issue. In other words, separating what we know from what we think it means is key to coming up with efficient defect resolution, to quickly getting to the root cause and the correct fix, rather than spending time going down paths that are not going to lead us to the answers. So I want to challenge you to apply these principles in your day-to-day software development. Have a curious mindset when the software isn't behaving as you expect. Ask yourself what assumptions are failing in order to produce the issue that you're seeing. And keep a very clean separation between what you know and what you think it means. I want to thank you so much for watching this video. I hope it's been helpful to you. I would be grateful if you would leave feedback for me in the comments below, what you liked, what you didn't like, any questions you might have. And please stay tuned to this channel for future videos on defect resolution, as well as other topics related to delivering maximum value as a software developer. I look forward to serving you again in the future, and until next time.